These are your instructions. In general, you just need to follow the PowerPoint. Please make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on each slide. Don't forget, if a slide asks for homework, send it in via Show My Homework, and if a slide asks for Educake, don't forget to do it by the date given. This is your starter activity. Can you remember what the formula for calculating acceleration is? And can you remember what the units of acceleration are? Stop the recording here while you think. So you should have come up with this. Acceleration is equal to the change in velocity divided by the time taken. And we normally write that A equals delta V divided by T. And acceleration is measured in meters per second squared. These are our objectives for this lesson. We're going to be talking about uniform acceleration, so we want to calculate the velocity of an object which is accelerating at a constant rate, and we have a new equation that we need to learn how to use, v squared minus u squared equals 2as. When something is speeding up or slowing down at a constant rate, we call this constant acceleration. It's also sometimes called uniform acceleration. A good example of this is the acceleration due to gravity. The acceleration due to gravity is called g, and it is equal to 9.8 meters per second squared near the Earth's surface. So everything on the surface of the Earth or close to the surface of the Earth is subject to this acceleration. This is the equation for uniform acceleration, and at first glance it does look quite complicated. So let's go through the terms one at a time. In this equation, on the left-hand side, you have v, which is the final velocity measured in meters per second, u, which is an object's initial velocity measured in meters per second, and on the right-hand side, you have 2 times a, which is the acceleration measured in meters per second squared, and s, which is a distance measured in meters. The full equation reads v squared minus u squared equals 2as. Now you don't need to memorize this equation because if you need it, it will be given to you in an exam. What you do need to be able to do is to rearrange it. Now, to get some practice in rearranging equations, follow the link below to a video which shows you how to rearrange lots of our commonly used physics equations. Let's have a look at an example. A ball has been dropped from the top of a building. The velocity of the ball when it is 2.25 meters from the ground is 0.6 meters per second. Calculate the velocity of the ball when it reaches the ground. You can assume there is no air resistance. Now the difficult part of this question is working out what they've given us. So if we look carefully at the question, S is the distance, and that is given as 2.25 meters. So we know what S is. U is the starting velocity, and that is given here. The acceleration due to gravity will be given to you in the question. So in this case, we want to work out the final velocity when it reaches the ground. So we're looking for V. Now it's important to do this step, working out what you already know, what's given in the question, and what you need to find out. So, having done that, first of all, write down your equation. V squared minus u squared equals 2 times a times s. Now we need to rearrange it. V squared equals 2 times a times s plus u squared. Then you can substitute all your figures in, and it gives you a figure of 44.46 for v squared. To find v, you take the square root of it, and that equals 6.67 meters per second. Now this is one of the most difficult questions that might come up. Here's another worked example for you. A car is traveling at a velocity of 8 meters per second. It accelerates by 2 meters per second squared to a final velocity of 12 meters per second. Calculate the distance traveled. So in this question, we know the initial velocity, which is u. We know the acceleration, which is a. We know the final velocity, which is v. And we want to calculate the distance traveled, which is s. So you can write all of those things down. Then write your equation down. V squared minus U squared equals 2AS. This time we need to rearrange it for S. So S equals V squared minus U squared, and all of that divided by 2 times A. Substitute in your figures, put it into your calculator, gives you S equals 20 meters. Here's another acceleration worked example. A cyclist is moving at a velocity of 3 meters per second and accelerates to 5 meters per second over a distance of 50 meters. Calculate the acceleration of the cyclist. Now this time we know the starting velocity u and the finishing velocity v and the distance s, and you want to work out a, the acceleration. So you can write all of those 4 things down. Then write your formula down. V squared minus U squared equals 2AS. If you rearrange that, A equals V squared minus U squared divided by 2S. Substitute in your figures, gives you A equals 0.16 meters per second squared. Your final task for this lesson is to take a picture of the work from this lesson in your book and send it via Show My Homework to Mr. Rahman by the 15th of May. Thank you.